Okay, so today we'll start with something that we read in our classes 8, 9, 10. That is known as geometry, more commonly known as Euclidean geometry. So in that, I'd like to start with something, one of the most basic curves, that is called a circle. So there are many theorems for circles. Like, you already know what is a circle, right? So let me start by drawing a circle. So this thing is called a circle. Now you might already know that it has one thing. This is its center, correct? And any point, the locus of any point on the circle is at an exact equal distance from the center, and that distance is called the radius. Okay, I'm sorry for my handwriting, by the way. It's generally this bad. Okay, so there are many theorems that you will keep on learning. So first of all, we'll just brush up quickly. I'll not spend much time on that. Okay, so one of the theorems is, let me draw a circle first. This is a circle. Okay, and let me go back to my previous slide. Another thing is that from any point on the circle to any point on the circle, so any straight line which connects two distinct points of a circle, it is called as a chord of that circle. Okay, understood? And any line that is just touching the circle at a single point is known as tangent to the circle. This is very basic. We're just starting with it. And we all know that the tangent and the radius or the diameter of a circle is perpendicular to each other. This is the symbol for 90 degrees. This is in degrees, which is same as pi by 2 in radians, right? Okay. So, any more thing if I'm missing? Okay, wait. And you all know what is the diameter, right? If this is the radius, diameter will be the longest chord. Always remember, it is the longest chord of a circle, which definitely becomes 2 times the radius of the circle. Okay, so moving on, we come back to what we had started, that is coming to some theorems. Okay, so one of the theorem will be that when we draw any perpendicular line, let me draw a chord first. So this is one chord of the circle. Okay, let me show its center. This is the center. So when we draw any line from the center perpendicular to this chord, okay, let's see what happens. I guess it is visible to you guys. Okay, these are the extension lines, these are the 2 radii, right? So eventually triangle ABC becomes an isosceles triangle. Right? We know, since the 2 sides are equal. Okay, very good. So 2 sides are equal. This means these 2 angles are also equal, right? You all know that. So let it meet at this point D. Let's find out how much is, and if we say so, right angle, base and hypotenuse. We all know congruent triangles, right angle, base and hypotenuse. If these are same, so this is the base, this is the hypotenuse, and right angle is there, base is there, hypotenuse is there. Base is AD, which is common to both triangle ABD and ADC. Hypotenuse is the radius of the circle AB and AC, right? Therefore we can say that triangles ABD is congruent to, congruent either you can write like this or you can give a tilde. We give a 3 to show that they are congruent. I hope you know the congruency rules. Triangles I have not included in this chapter. I've just started with circles. Triangle ADC, right? Or else if you already, so this is one one way of going about it. We have proved it congruent. Hence, since the triangles are congruent, so the third side will also be equal, that is BD equals to DC. Hence D is the midpoint. Hence D is the midpoint, right? So what is the final theorem? We all know that, right? That any any line that is drawn perpendicular onto a chord of a circle from the center of a circle is, actually let me rephrase it. Any line that is drawn from the center of the circle to the midpoint of any chord of a circle is always perpendicular to the chord. Okay, so this is one way to rephrase it. Okay, or we can say the other way around, that any perpendicular drawn from the center of a circle to any chord always bisects the chord. Okay, so remember this. Take a good look at it. Nice. Next we'll go on to do one more form of it. It is called equal chords. So this is another theorem. So let's say it is the property of equal chords. Let me draw a circle. So this is a circle. Now we'll draw any two chords. Okay, let me draw the center. So the theorem which comes from that only is that equal chords, if these two are equal, this is how you show equal, that this length is equals to this length, AB, CD. If you give this sign, this C1 not able to understand. If you give this sign, this very sign, it means that these two lines are equal. So if two chords are equal, if AB equals to CD, then two lines drawn, then its distance from the center will also be equal. Then OX equals to OY. This is the theorem. Okay, how to prove it? Extremely simple, you know it, right? So AB equals to CD. From theorem 1, let us name the previous slide as well. This is theorem 1. Okay, so this slide, and this is theorem 2. So from previous slide we already know that whenever any perpendicular is drawn from O, means the center of a circle, to any chord, it bisects the chord. Means AX equals to BX equals to, and since X is the midpoint, X equals to BX equals to AB by 2, right? Very nice. And similarly cy equals to dy equals to c dy2. Now given ab equals to cd, it means ax equals to cy equals to dy equals to bx. Understood? All of these individual lengths are equal. Again, when I am giving a single stroke, it means that part is equal to that part, like that. Okay, very nice. So next we have to prove that ox equals to oy. For that we'll join these two lines. Very rash drawing, I must say. Still, I'll try to rectify it once. Okay, so let's draw a good line. Okay, that's a good line. Okay, that's also a good line. So ox, so now what is oa? That is the radius of the circle r. What is oc? That is the radius of circle r. Okay, so what does ox automatically become from Pythagoras theorem? I guess you already have learned in classes 6, 7. That is root over of r square minus ax square. Correct. And oy is r square minus cy square. But since ax equals to cy, therefore ox becomes oy. Hence proved. Okay. So these two theorems are very nice and very important. With this you can solve a lot of important problems in this chapter called circles, which you generally encounter in classes 8, 9, something around that, and it continues to keep on giving you results till your engineering drawing classes in your BTech and even after that. So these will be the very fundamentals that you will be learning in this course. So I wish you all have listened to it well, and I'll keep on giving more and more videos regarding this, and we'll continue solving more and more problems. Okay, so right now what to do? So with these two being learned, why not we do one or two problems? That will be nice, isn't it? So generally whatever we have solved, I'll give you the name of the book. The name of the book is A New Course in Geometry by Walker and J. Miller. Okay, this was studied throughout. Its publications is Orient Longman. Okay, so I'll be following this book throughout because very nice problem set is there. It was used in my very own school when I studied in St. Xavier's. From class 5 to class 10 in Durgapur, West Bengal. Okay, so if you want, you can buy this or anything, whatever. These theorems are very basic, you can get it. The main thing is how you apply these theorems and how your imagination helps to recreate a new sum and help you solving it various other problems in geometry. Okay, so let's start. It's an exercise 37, problem number 23. Okay, so it says that two circles are there with center A and B intersect at P and Q. Okay, move it so it has intersected very nicely. Okay, so right now I have to name what is this written. Okay, two circles with centers A and B. We'll name this center as A, name this center as B. intersect at P and Q. So this point is P, this point is Q. AB and PQ, AB and PQ cut in O. Prove that O is the midpoint of PQ. So first thing we have to prove is O is the midpoint, that is PO equals to OQ. We have to prove. Second thing we have to prove is AB is perpendicular to PQ. So these are the two things we have to prove. Okay, very nice. Okay, so we'll start with, where has it gone? So we'll start on a fresh page. This is one circle, this is another circle. A, B, P and Q, right? Two lines. Whenever I draw a line, it's very bad. Let me join it properly. Okay, A, B, P and Q. So we have to prove that it is a midpoint. This is O. It cuts in O. Let me rename it as R1, R2. This also is R1 because same circle. 2. So you see R1, R2. So triangle APQ is congruent to triangle BPQ on the basis of side, side, side. 3 sides are equal. No, sorry. I've written the wrong triangles. Extremely sorry for this. So triangle, this will be the two triangles. This is one triangle, this is the other triangle. So what are the names of it? Names of it is ABP and ABQ based on side, side, side. Okay, common side AB and AQ equals to AP and BP equals to BQ. This is how we have come to the conclusion that triangle ABP is congruent to triangle ABQ. Very nice. So as a result of this, we'll get some properties of congruent triangles, that this angle is same as this angle and this angle is same as this angle. So we'll write down in words. Angle PAB equals to angle, write the implies sign, implies triangle angle PAB equals angle QAB and angle PBA equals angle QBA. Okay, so these are the results. Now another time, so we'll apply this. Now we'll see triangles triangle AOQ and triangle AOP. We'll try to analyze these triangles. AO is the common common side, right? Then AP equals to AQ, this is the second side that is equal, and we have also one included angle PAO, which is same as angle QAO as proved from the earlier point. So we have two sides and an included angle similar, which means we have these two triangles as congruent, which in fact means, which leads to PO equals to OQ, and which proves our first answer, that O is the midpoint of PQ. So AB meets PQ in its midpoint O. Okay, so first thing is already proven. Now another thing was that AB is perpendicular to PQ, though it's a known theorem. Already know it, that the angle bisector of the vertex of an isosceles triangle is always perpendicular to the base. You know it now. Here triangle PAQ is an isosceles triangle. Are you able to see it? I'll rub this. And prove the very next point. It's very easy to prove. Once we know what we know, I'll keep the final thing only. We have already proven this point, that PO equals to OQ. So we already know that. So from now we have already proven that the triangle PAO is congruent to triangle QAO. That's how we got the first answer, that is this one. Okay, but congruency will give you one more point, that is angle POA equals to angle QOA, right? But since PQ is a straight line, right? Therefore angle POA plus angle QOA, that must be equals to 180 degree. Implies that now POA equals to QOA, 2 times angle POA equals to 180 degrees, which means angle POA equals to 90 degree, which is same as angle QOA. Therefore this is our answer 2. Okay, very nice. So this is one of the very important things, that when two circles meet, and you should remember this, not that it is outcome of outcome of solution of a problem. You will not remember the essence of it. You should remember the essence of it, that whenever any of these are general, any two circles which are meeting at points P and Q, they are meeting at any 2 points. So the line joining the center of the two circles will always bisect the common chord at right angle. Okay, line joining the center of the two circles will be the perpendicular bisector of the common chord. This is what we learn. Okay guys, that's it for today. The video is becoming long, so I'll just stop now, but we'll come back with more and more circles, and we'll continue with this Euclidean geometry. As you develop liking, please do share with me more and more problems, and after few of my videos, if I'm gaining more and more subscribers and requests from you, then I'll give you the links to certain books that you can go through. Okay, and please keep on doing more and more sums. Okay, and you should also do what thing? You should like, and you should share this video, and you should do one more thing: subscribe. Oh, what am I doing? Subscribe button, it is in red, so please subscribe. to my channel. Okay, channel name you already know it, will keep on coming. It is ESTI, and this is my geometry series. In case you are interested in anything more, do share your comments, and guys, please study, okay, and live your life, love whatever moments you are spending, and learn from every bit of it. Bye.